Hey guys, this is problem 2. So for the problem 1, I used virtual work to get the displacements. Notice that you always need to get the displacements somehow, or at least for the method we've been using so far requires you to start by finding the displacements and then setting the displacements, expected displacements equal to 0. In order to find those displacements, in number 1 we use virtual work. In number 2, I recommend that you use moment area because we're working with a cantilever, and I think moment area is the fastest way to go. I tried using differential equation method at first, and that ended up taking a very long time, and I did not get very good results with that one. So yes, I recommend trying moment area for this problem. So let me see. Here problem is it's a roller, or 2 point loads in a roller. So to start with, you should break this up into, well, you have choices on which things you can remove. I would just remove the roller. I think if you remove the moment support, that might actually make things a little bit easier for some cases. But then you have a simply supported beam with an overhang, and I don't like dealing with overhangs. I'd rather just deal with a cantilever. So you can split this up into 3 components. Split this up into this. And of course, yeah, you don't need your Q diagram, so you don't need a 4th diagram. So let's call this 1, 2, and 3. Let me note where B is on here. We're interested in the deflection at this point, and at this point. So in order to get those, we just need to use, let's look at our moment area equations again. So first things first, let's draw our moment diagrams. Actually, yeah, I'll let you draw the moment diagrams. Sorry, this one's not. We're interested in the moment here. The moment at by, not by is not under P. Yes, so I'll let you find the moment equations yourselves, the moment diagrams yourselves. Once you have those though, you recall that TBA, the deflection at point B with respect to the tangent at A, because the tangent at A has a slope of 0, this happens to be delta B. And we're working with, if we work with case 1, then this will be the this will be the do you guys remember this? A to B times centroid to B. Yes, this is your equation, I believe. Am I missing an L here? I don't think so. I think this is your equation. That should give you the right units. Centroid diagram to B, and then for this is row 1, for 2, for 3. For number 2, you just need to do the same thing. Your diagram will be similar. This will be one triangle, another triangle, and a big triangle. The interesting thing for number 3 is that when you draw your diagram, I'll just give this one to you guys. This is number 3. This is triangle 3. You're interested in the centroid with respect to this point. So this is going to cause some problems because you're only interested in the moment. You're only interested in this moment. You're not interested in the moment of this area. You only go from A to B. From A to B. So you don't have a true triangle here. You have a trapezoid shape. And I don't think trapezoid shapes are very fun to work with. Finding the center of area of this is a little bit tricky. I would just split this up into a triangle and a rectangle. But yeah, just keep following the steps. That should be, you should be able to get to the same thing. The results I got for this, your reactions are AX equals 0, obviously. Y I got to be, AY to be 0.3125 P upwards. I got MA to be 0.125 PL, and this was positive, counterclockwise positive. And I got BY equals 1.6875 P. So yeah, let us know if you have any questions. Let me know if you guys get different results. My shape, the diagrams that I got are the shapes are proportional and correct, but I'm not exactly sure on the values. Because like I was saying earlier, RISA does not give you, or I don't think RISA is very accurate for the way we're solving our problems. RISA is more accurate. This is giving you a more accurate solution, but for the methods we're using, it's not correct. So I need to double check. But yeah, let me know if you're getting values that are close. Close to this, but not quite the same, because I probably have some small, I'm hoping small math errors in here. But yeah, let us know if you have any questions.